Okay, let's start chapter 9. So for chapter 9, we're going to be dealing with two samples. Sometimes the data will be pooled, sometimes we'll use unpooled. It really depends on the problem. There's also some debate on when is using, which one is better used in each situation or which one's safer. In general, if you don't know the standard deviation of the populations, or you know that you're not sure if they're equal or not, you should use unpooled. Normally you use pooled when you know that the standard deviations of the population are the same. There's a lot of other stuff that goes into it. We're not going to get too heavily focused on that in this class. So for these next few problems, we're going to consider we're using pooled data, and then later on we may not use pooled data, okay? So this section will focus on hypothesis tests on two proportions. So we're going to be taking two samples and then using both of those samples to compare proportions from two different populations, okay? This is just a bunch of fancy notation that we're going to be using, and then here is the formula. So in order just to find the test statistic, we're going to have to use this whole formula, okay? Just kidding, you guys. I'll show you how to do it once, and then we're just going to use the calculator, okay? So yeah, don't stress too much about this. There's a few things that I want to talk to you guys about it, but then we're going to pretty much use the calculator to hit enter. I don't want you guys to spend 20 minutes trying to do this calculation and then being off by a decimal. So in reality, we won't be using that formula often. We will be using the calculator. However, I wanted to show you one, okay, to show you why I'm not making you do it. Okay. So it says, in a study of red-green color blindness, 500 men and 2,100 women are randomly chosen, or randomly selected and tested. Among the men, 45 had red-green color blindness. Among the women, 6 have red-green color blindness. Is there sufficient evidence to test the claim that men have a higher rate of color blindness than women, red-green color blindness than women? Use a significance level of 0.01. So they want to do our null. So remember, we're going to kind of go and do it our way. So our first thing will be the claim and the opposite claim. Okay. Hold on one second. Let me get the right stuff. Oops. So right here, this is what's important for us. This is what the null will look like, and this is what the alternate will look like. Okay. So the null will always be that P1 is equal to P2. And what that means is you're saying that the null is assuming that population 1 and population 2 have the same proportion. And the alternate is saying they don't. Either one is smaller than the other, one is bigger than the other, or just they're different. We don't care which one's bigger or smaller, we just know they're different. Okay? So that means in this calculation right here, think about it. If P1 equals P2, well, when you subtract them, what would they be? Well, this would actually be 0, right? That would be gone, right? That would become a 0 because P1 minus P2, if P1 and P2 equal each other, that's 0. So what you're really left with is this formula, okay? So a few students ask me, when you do the formula, why don't you calculate this? Where did that go? Well, it's because it's 0 for this problem, okay? So we come up here and we're going to work with our claim. So we already know the claim is that population 1 is equal to population 2 proportion, okay? And then the opposite claim, let's see, it says test the claim that men have a higher, oops, maybe I shouldn't write it like that, now kind of throw you guys off, that men have a higher rate of color blindness than women. So we're going to say that men are population 1 and women are population 2 because they listed them in that order. So we're going to say P1 is greater than P2. So then this means that P1 is less than or equal to P2. So now our step 2 will be the null and the alternate, just like we've been doing. And the null will be that P1 equals P2. And that's what this said would happen right here, right? And then the alternate would be that population 1 proportion is greater than population 2 proportion, meaning that men have a higher rate of red-green color blindness than women. Okay, so that's what we're trying to test. So then in step 3, we're going to say that alpha is worth 0.01, and we know this is a right tail test. Okay, because once again, hopefully you guys are getting tired of me reminding you, but because of the alternate hypothesis. Okay, so compute the test statistic. So I computed the test statistic way over here, okay? So I found this formula that they gave me up above. So this formula says p hat 1 minus p hat 2 minus p1 minus p2 divided by the square root of p bar q bar over n squared, blah, 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 blah. Okay, so you guys get the point. In order to calculate p bar, I had to add the two x's, which are the people that actually had red-green color blindness, and then divide it by the two populations, okay? And then let's see here. In order to find p hat 1 and p hat 2, population estimate 1 and population estimate 2 for proportion, I had to divide them. So I came over here and I built all of these things. I found p bar, which is 0.0196. So if I know p bar, I know q bar is 0.9804. I know p hat 1 is going to be 45 out of 50 because 45 men had red-green color blindness out of the 500 tested. And then 6 out of 2100 is 0.0029 because 6 out of 2100 men or women had red-green color blindness. Then I came and I used this formula that was listed. I plugged all my values in and I got 12.628. So this is a bit of a bear. This is a lot of work, okay? So what I'm going to choose to have you guys do for this course instead is I'm going to choose to have you guys do this on your calculator. So let's all take out our calculator real quick. So this will be step 4. Okay, so we're going to go into stat, test, and then we're going to go to 2PropZ test. So 2PropZ test on my calculator, it's number 6. So I'm going to do 2PropZ test, and then I'm going to list what they want. X1 is equal to 45, N1, if you were in class, this is how I would have you write it down, is equal to 500. And then we have X2 is equal to 6, and population 2 is 2100, that's the women. So this is women, this is men. Okay. So now let's see what we get for our Z equals. So I'm going to go and enter these in. So X1, N1, X2, N2, and then I'm going to do greater than P2, right? Because you're saying that P1 is greater than P2. If it was less than, then you would have done the middle one. And if it was not equal to, you would have done the not equal to. So I'm going to go to calculate. And it tells me that Z is worth 12.628, I guess, or technically I could say 12.63. I'll do 12.628 since we have the calculator right here. So this is my test statistic, okay? So instead of having to do all of this and get the same answer right here, I just did 2PropZ test on my calculator. So definitely have all these written down somewhere where you can have quick reference to them and know when to use them. Why am I using this one versus another one? Make sure you know when we use this, when we had a population proportion and we were dealing with 2 samples, 2 population proportions, and we were comparing them, okay? So now, here's the really, really nice part. Determine the p-value. Well, it tells me that p-value is equal to 7.63, I guess, it doesn't really matter, times 10 to the negative 37th power. Now, why is this such a small number? Okay, and I didn't even do the drawing right now. I just didn't have enough room, but you guys could do the drawing over here. Right, and it's a right tail test. Okay, why is it such a small number though? Why do we have times 10 to the negative 37? That's so close to 0, I can't even tell the difference. Well, the reason it's so small is look at my z-score. You guys remember that any z-score over 2 was already starting to be like no chance. Z-scores over 3 were like almost a 0% chance of happening. So imagine a z-score of 12. The probability of that z-score happening is very, 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 very slim, basically almost 0. And that's when we get 7.63 times 10 to the negative 37. We're saying that it is basically 0, okay? So statistical decision and justify. So let's go to our step 6, and everything's still the same since our p-value is less than or equal to our alpha. So we have 7.63 times 10 to the negative 37 is less than or equal to 0.01. We reject the null and accept the alternate. Okay, so now state your conclusion. We say there is sufficient evidence or enough evidence to support the claim that, and now let's look at our alternate hypothesis. Our alternate hypothesis tells us that population proportion 1 is in fact greater than population proportion 2. And we said that this is our P1 and this is our P2. Women are P2, men are P1. So then we're supporting that men do have a higher proportion of red-green color blindness or a higher rate. So there is sufficient evidence to support the claim that men have a higher population proportion of red-green color blindness. Okay, and this is our step 7. So everything's the same. We're still doing everything the same. So again, if you get chapter 8, you're going to be fine with this section as well. The only thing that's kind of weird is the null will always be P1 equals P2 for population proportions. And that's not really weird, but it's not a number. You're just saying that the first population proportion is equal to the second. So that's kind of the accepted, you know, hey, the two population proportions are the same. And then you're trying to disprove that with your alternate, okay? You're trying to say that you can find it otherwise, okay? So you guys take a minute, let's write this one down. So pause the video, okay? Or maybe I'll read it first. So the initial test of Salk vaccine, 33 out of 200,000 vaccinated children later developed polio. Of the 200,000 children vaccinated with a placebo, meaning not the real thing, 115 later developed polio. At a significance level of 5% or 0.05, test the claim that the Salk vaccine is effective in lowering the polio rate. Does it appear that the vaccine is effective? Conduct a hypothesis test. Okay, so we're going to do everything like before. Okay, so you guys do your step 1, step 2, step 3. So take a minute, write all that down. Pause the video, see if you can set all this up. Use your calculator to find the test statistic. Okay, hopefully you guys are back. I have everything ready to go, so let's start going. Let's start writing it down. So we have that the claim and the opposite claim. Remember, they're both claims, just one is the opposite of the other. Test the claim that the Salk vaccine is effective in lowering polio rate. Okay, so effective would mean there are less people that got polio with the vaccine versus the ones that didn't. So we're going to say population 1 is less than population proportion 2. So that the proportion of people that got polio is less than the people that got polio in population 2, okay? The proportion, okay, the ratio, all right? So then that means this has to be greater than or equal to P2. So now we know our null, our null is P1 equals P2, but again, we know that's gonna happen. And we know our alternate is P1 is less than P2. We know our alpha is worth 0.05, and we have a left tail test. Now we're doing a little bit less with the drawing because they're giving us the p-value right out of the calculator. So on some of these, you can kind of start skipping the drawing and just jump straight into the p-value because so much of this chapter is done on your calculator. Again, the reason I wanted to show you guys over here this is actually what your calculator is doing. By you plugging everything into your calculator, it's doing all of this for you, okay? So don't lose track. This is all still happening. You are still using the samples together combined with the ratio. you're doing all these calculations. It's just the calculator's doing it for you. Okay, so don't lose track of that. So it says compute this test statistic. So I'm going to go back to my calculator again. I'm going to do 2 PropZ tests. Okay, and again, I'm going to use, and let's say P1 is vaccine. And we'll have, let's see here, 31 or 33, and N1 is 200,000. And then no vaccine, X2 would be 115, and N2 would be 200,000. I've also heard a lot of times, guys, when you're using this pooled approach with population proportions, that you're allowed to do it, especially when the sample sizes are identical or really darn close to the same. Again, in the previous problem, we're using it anyway because I'm asking you to. But in reality, technically, to use the pooled approach, you're supposed to either know the standard deviations are the same, or I've also discussed with other people that if the sample sizes are the same size as well. But it all has to do with the variance involved, okay? Those of you that go on further in statistics, you'll spend more time on that. So we have our 2 population 1. Let's call this P1. Let's call this P2. Maybe I should write it below it. Okay, test statistic is equal. When you plug this into your calculator, you should get negative 6.742, I believe. Let me do it again. I already did it once, but let me do it again. Let's go to stat test 2 PropZ test. We got 33 out of 200,000. We have 115 out of 200,000. And we have less than this time. Yep, I get negative 6.7416, so 742. This is equal to my Z. This is my test statistic, right? We now have our test statistic. Now, if you understand why it's negative, it's because we're doing a left tail test, so it's way on the left-hand side. So we would have, right, like this, and then it would be like somewhere way over here, right? And then we would shade this way. But again, we already know that the p-value is going to be super small. Why do we know the p-value is going to be super small? Because our z-score is so far left. A negative 6.74 z-score is extremely negative. That is a big negative z-score. Okay, so our p-value, when I've used my calculator, let's round it off to, oh, we don't even need to. It's 7.88 times 10 to the negative 12. And again, I already know that I'm going to reject the null because this is such a small p-value. So we could say p-value, we could write it quick, p-value less than or equal to alpha. So we have 7.88 times 10 to the negative 12 is a very, very small number, close to 0. That is definitely less than 0.05. So reject the null and accept the alternate hypothesis, okay? So then it says state your conclusion. So we say there is sufficient evidence to support the claim that the population proportion of vaccinated or population proportion, how do they word it? Proportion develop polio is less in vaccinated versus unvaccinated population compared to unvaccinated. or non-vaccinated children. So basically, this is a really long-winded way of saying that the Salk vaccine does appear to work. There is evidence to suggest that it is working because our data shows us that population 1, which was children that were vaccinated, definitely had or appeared to have a smaller population that still got polio versus the ones that were unvaccinated or had non-vaccinations. Okay. So yeah, sorry, that was pretty long-winded. Okay, so confidence intervals for two proportions. So we can kind of lead back into what I ended chapter 8 with. So if we wanted, we could go, okay, so I'm just going to show you guys as the confidence interval for two proportions will be used to estimate the difference between the two population means, P1 minus P2. Now remember what the null said? Remember the null said that P1 equaled P2, okay? Now take that back to the formula. So if P1 minus P2, if the null is true, then that means that equals 0, right? If the null isn't true, then that means it does not equal 0, okay? So that means that if we're just trying to find out a difference, that means that the alternate P1 minus P2 does not equal 0. Think about that. Because if P1 equals P2, this means that P1 minus P2 does equal 0, right? So just think about that for a second, okay? So if you want, I guess you know what would be easier if I wrote it like we've been doing. P1 does not equal P2, but this implies that P1 minus P2 equals 0, and this implies that P1 minus P2 does not equal 0. So that's what you're getting yourself into. That's why when we look up here, it says the confidence interval for the difference between two population proportions, P1 minus P2, is given by this long formula. Once again, we're not going to do that long formula, but we could if we needed. And then it says if 0 is not in the confidence interval, then there is a difference, okay? Because remember, the null says that they equal 0. So if 0 is in that interval, then that means the null could be true. And then we can't accept that there is a difference. But if 0 is not in the interval, then you are allowed to say that there does appear to be a difference between the two population proportions. If 0 is in the interval, then you have to say that there does not appear to be a difference. So make sure you understand the wording of this. It's kind of a weird way to say it, okay? So if there is a 0, then you can't determine a difference. And if there is not a 0, then you can say there is a difference between the two population proportions. Okay, so let's look at a problem. And again, we're going to use our calculator. So we're going to do 2 prop Z interval. Okay, so not Z test. We're going to do 2 prop Z interval. Okay, and we're going to do population 1. So it'll give me my interval here. But I'm going to use population 1 and I'm going to use population 2. Okay, so this will be surgery and this will be splint. Okay, so it says carpal tunnel syndrome is a common complaint that results in wrist pain. Some people have splint treatment where they are splinted, and some people have surgery. A trial was done to test the effectiveness of these methods. A total of 156 patients who experienced carpal tunnel were treated with a splint or surgery, then evaluated later for carpal tunnel. Among the 73 patients treated with surgery, 67 were found to have successful treatment 1 year later. So let's see here. X equals 67. And so this is X1 and N1 equals 73. Okay, so 67 of the 73 were successful surgeries. And then it says 60 out of the 83. So X2 is equal to 60 had success out of, over N2. Out of the 83. And again, I'm just writing down information from the problem, okay? So let's go to our calculator once again. Let's go to stat test 2 prop Z int. I think that's way at the bottom. Yeah, so on mine it's letter B. So 2 prop Z interval, and it asks for X1. So this is why I wrote these down. So 67 successes out of 73. Then we have 60 successes out of 83. And our confidence level is 95. Okay, so it gives me 0.07, I guess we could say 0.080 if I round off to 3 decimals, and this one is 0.30, I guess it's 0.310 if you want to round off to 3 decimals. I basically got 0.07985 and 0.30999, okay? So now the question becomes, look at this interval, okay? So the next part says, does the confidence interval support that there is a significant difference between the 2 treatments? So is 0 in that interval? 0.08 to 0.310. Does 0 appear in that interval? The answer is no, it does not appear. So if 0 is not in the interval, then there is a difference, okay? So since 0 is not in our confidence interval, there does appear to be a difference. So let me kind of warn you guys something right here. So some people, what they do, what I've seen in the past is they just do this. Well, they just say 67 divided by 73, and they just say 60 divided by 83, and they just get decimals. So they say 67 divided by 73, oops, 67, and they get 0.917, and then they do 60 divided by 83, and they say, oh, that's 0.723, okay, if you approximate. And they say, hey, look, 0.917 is bigger than 0.723. There must be a higher success rate. Well, that's just samples, though. Remember, you can't just say that. Now, that may give you an indication that, hey, I believe that the surgery does appear to be working because my sample seems to show that. But then you still have to go through and do the test. You can't just say it is because of the sample. That's what the confidence interval does, okay? The confidence interval gives you the math to back you up instead of just 2 percentages of 2 samples. This is now saying that you are 95% confident that there does appear to be a difference in treatment. Now, does it say which one's better? No, we don't know which one's better. All we said is the 2 treatments do have different success rates. They don't appear to be the exact same. From our sample, it looks more like the surgery is a better success, but again, we can't make that statement. We can just say that based on the data, there does appear to be a difference in success rates for the 2 samples. Okay, let's do one more. So you guys pause your calculator now, or pause your test. Sorry, been doing too much math today. You guys pause the video real quick and try to set this one up just like I did this one, okay? Okay, so hopefully you guys are unpaused. What would the null be? What would the alternate be if asked, right? Well, we know the null would be P1 equals P2, meaning that there's no difference between the 2 proportions. And the alternate would be P1 not equal to P2. But each one of these lead to the idea that P1 minus P2 equals 0. And this one is P1 minus P2 is not equal to 0. So that's what we're working with here. Again, we're going to go to prop Z interval. So we're going to build this confidence interval. And then we're going to do P1 and we're going to do P2 over here. And let me see here. This would be what? X1 equals 22. So it says among 5,000 items randomly selected at American Air or luggage at American Airlines, 22 were lost. So 22 were lost out of 5,000. P2, let's have that be among 4,000 items. So this would be N2 equals 4,000. At Delta, 15 were lost. So X2 equals 15. So this is Delta. This is American Airlines. Okay. So let's plug this into our calculator. So second, oops, quit. So we're going to go into stat test. And again, on mine, it's letter B, to PropZ int. This time, 22 were lost out of 5,000. This 15 were lost out of 4,000. And we're on a 99% confidence level. So I get negative 0.0028, comma, 0.0041, I guess. Okay, so what does that mean to us? Based on the results, does there appear to be a difference in the way they handle luggage, basically, is what they're trying to find out. So we say, since 0 is in the confidence interval, there does not appear to be a significant difference in lost luggage proportion between American Airlines and Delta. Sorry about that, you guys started running out of room. Okay, so whenever 0 is in the confidence interval, there does not appear to be a difference, okay, because that means when you subtract them, you get 0, and that means 0's in here. That means they could be the same. Now, we don't know for sure if they are the same, but we're saying it is possible that they are the same population proportion. When 0 is not in there, then you know for sure they're different, okay? So that's one way you can use that magic number of 0 for confidence intervals, okay? So let's see here. I think that's going to be it for chapter 9's first video. I'm going to go ahead and stop the recording now, and you guys watch this and you should be able to get started on chapter 9.